Alright, good to go.
This expedition is really unique because no one's ever done this before.
Let's go!
Scientists don't own ships. We usually bid for ships. And so to have a vessel like Dagon and the team that it has, we can answer questions like this. And it's one of scale. Everyone from oceanographers to geologists to ecologists. We're here to fill pieces of the puzzle and get a complete, holistic view of the deep sea in the Pacific. My name is Todd Bond. I'm Chief Scientist here on this leg of the expedition. I'm filling Al Jamison's boots, and part of his role is to really coordinate everyone. He's the ringmaster, the juggler, juggling all the different disciplines.
So this is our main engine control room.
At the moment, Inkfish is driven by the scientists, and so the leads are allowed to put enthusiastic, early career scientists onto the ship and go, we trust you and your ability. You answer the questions that you feel are the most important.
I'm really pumped. This is an incredible opportunity that not many people can get.
Copy that.
We're excited with the new science team on board. We've just left Tahiti now, bound to the first lander position, one of the 7 lander set what we have to do from Tahiti to Honolulu.
This project as a whole is made up of 6 lands. We have 3 weeks to do each crossing. And during that time, the depths that we will be sampling are anywhere from 4,500 to about 6,000 metres.
All right. Got everything loaded if you want to take a look before we go on to the next bit.
Brilliant. Devon is on here to understand how the geology and how the geomorphology of the areas that we go change through space.
From the multi-beam, this is brand new mapping that we're doing, which will not only be interesting because it'll be the first of them data sets made available, but also you might find new features or find new processes of how these things are formed. Kind of interested in these linear features that are perpendicular to the fracture zone strike.
Cool, I'll get those points together and get them up to the bridge. Maybe up to 12 hours.
Because it is a remotely sensed data set, we drop landers in certain locations as a way to validate.
Oh, good to go, good to go.
Mate, first lander and she's already got it all sorted. How good's that?
Megan Cundy, she's been brought on board to understand how the animals are changing from San Diego to Hawaii and then Hawaii to Tahiti, but then also with depth as well.
In setting up the lander, we've got a couple of different bait attachments to get some animals to actually get in there. And then we have 2 cameras that we attach to the landers. And my role is to do the video analysis, counting the abundances of all the different species that we find on the video footage.
Another team member is Dr. Jess Colbush. She has an incredible background in oceanography.
2 minutes.
On the lander, we get data in a few standard oceanographic measurements.
Let's go!
And my job is to understand the internal variability in the ocean depth. Currents, temperature, salinity, deduce things around climate change. And there's also biological oceanography, which is to do with processes, which means that life can be sustained at these crazy depths.
The landers sit on the bottom for around 6 hours until we either tell them to come home or the timeout that we've preset releases the weight and it floats to the surface. Ten years ago, we might have got 1 or 2 lander deployments on a voyage, whereas this trip itself, we have 42 deployments For us as scientists, that creates power. The power to pull out what's normal and what might be specific and rare. Oh, what is that?
I don't know, fitted egg? But it's got like the face of a cascule.
There were a few really interesting little bits that came out from a first pass analysis. Back into the mud. Devon's gonna love that.
Is this the one you really wanted to see?
And having those three young scientists all trying to fill pieces of the puzzle and get this beautiful image of our marine systems is extraordinary.
On Site 7, you can see here that there's this anomaly where the temperature increased right near the bottom.
These are amphipods. We'll take them back to the lab in Perth and genetically test them.
Well, it's just definitely a fault zone.
We have been given the equipment and the license to really do what we want. And when we're allowed to be creative, that's when scientists do their best work.
Lights, you are clear to put sub in the water.
Okay, guys, all ready?
Watch you guys.
This is the deep submergence vehicle Buckanoa. We like to call it our elevator to the bottom of the ocean. And yeah, got one of the sickest jobs in the world. Apart from being this amazing engineering feat, what this vehicle does very well is navigate complex terrain and conduct surveys, filling the gaps between the landers.
Yeah, that position looks really good.
Operating this vehicle, you're in an area which you can pretty much guarantee that no other human is going to go back and see on any given dive. You might have a world-leading geneticist or geologist explaining the magnitude of what you're observing. All of the science that we're doing on here, it's truly a dream come true.
We have this ship with the equipment that it has and the team that it has for the next 5 years. And that's one of the really, really beautiful things. We're going to come out of this with one of the best spatial designs of deep sea science probably ever done. It's quite incredible to be able to do this.